So this is a great unit because you did this exact same unit last year, and so you are going to remember the relationships for sine, that sine is the ratio of the side opposite the angle to the right hypotenuse. What about cosine? Cosine is the relationship of the adjacent side to the hypotenuse. I'm just going to abbreviate there. And then tangent is the ratio of the opposite to the adjacent. Do you remember the easy way to remember these definitions? You do. It is Sohcahtoa. Sohcahtoa. And of course, I should have mentioned earlier, the hypotenuse is always your longest side across from the right angle. Opposite and adjacent are relative, right? It's about the angle. So these we're talking about angle A. This side would be considered opposite angle A, this side adjacent to angle A. So, and we know there's always working with right triangles, so they always work with the Pythagorean Theorem. Here's a 3, 4, 5 triangle. What would the sine of angle A be? Well, opposite is 4, hypotenuse 5. Cosine, similarly, 3 over 5, and tangent 4 over 3. If I switch to angle B, now the opposite is 3 over 5, the cosine is 4 over 5, and the tangent is 3 over 4. So the cosine of A, the sine of A is always the same as the cosine of B, and vice versa, and then these two are always reciprocals of each other. In the next one, it's 512, and I bet you know by heart the Pythagorean triple finishes with 13. So if I'm doing sine of angle A is 12 thirteenths and 5 thirteenths, and then tan is 12 over 5. And we introduced 3 new trig functions, the cosecant, the secant, and the cotangent. And these are what we call the reciprocal trig functions. Cosecant is 1 over sine, or hypotenuse over opposite, or in this case 13 over 12. Secant is 1 over cos, or hypotenuse over adjacent, or in this case 13 over 5. And cotan is 1 over tan, or hypotenuse over, adjacent over opposite, or 5 over 12. So how are we going to remember that? Well, you could always do the less popular Sohcahtoa. Not quite as cool as Sohcahtoa, but it works, right? Sohcahtoa, cosecant, secant, cotangent. Now we review some old friends, 30, 60, 90, and you remember the rule x, 2x, x root 3. But I want to have x here be 1. The side opposite the 30 is 1. So now the hypotenuse, 2x, is 2, and then the side that's x root 3 is just root 3. So you don't have to really have those rules there, but just knowing that the sides 1, 2, and root 3 work, right? Those work for the sides of the right triangle. I'm going to rewrite them. I'm just going to have them be right in the middle. 1, 2, root 3. So the sine of 30 degrees, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, have to rationalize the denominator, root 3 over 3. These are what we call the exact values. You could type it in on your calculator, it would give you like 0.5 or 0.866, right? And those are the approximate values, but anytime moving forward we ask you for these values, we want the exact values. Similarly for the 45, 45, 90, x, x, x root 2, easiest if the legs are 1. So we have 1 over root 2, which rationalizes to root 2 over 2. 1 over root 2 rationalizes to root 2 over 2, and 1 over 1 is 1. Cosecant of a 45 would be root 2. Here, root 2 over 1 again is root 2, and then 1 over 1 is 1. In the next few days, we are going to move towards really memorizing those values. Those will become like the ABCs for you of trig. The next page is when we're going to use the trig, right? We're going to actually use this Sohcahtoa to, solve things, right? Okay, sorry. So if we want to solve here, if A is 21, or A is 15 and C is 21, and you want to find B, what formula would I use with a right triangle? Right, A squared plus B squared equals C squared, right? A squared plus B squared equals C squared. So it doesn't matter what order you put it in, and you could just solve this on your calculator, and we're going to get, let's see, 221. Yeah, we can, let's see, 21 squared minus 15 squared, and then we got to take the square root, right? And so that's 216, so B squared is 216, and then square root of that. And I'm fine to have decimal answers, right? You would round 2 places after the decimal, which is 14.70. Perfect. But now getting into more of the trig, if angle A is 32, side C is 8, find A. Do you remember how we would do this? You'd want to look at Sohcahtoa. Is it a so, a ka, or a toa? Right, it's a so. The sine of 32 is opposite over hypotenuse. And we would solve that by multiplying both sides by 8, typing 8 sine 32 in our calculator, and rounding it to 4.24. The next one I have to fill in, side A is 63, or angle A is 63, side A is 9.7, and finding C. This is also a sine question. Sine of 63 is 9.7 over C. This is slightly different because you've got the variable in the denominator. So algebraically, you're going to divide both sides by sine 63. So just a little bit of different typing into your calculator, and when you solve that, you get 10.89. And then we're talking a little bit about how to use inverse trig functions. If A is 11 and B is 21 and I want to find angle A, that's a tan question. The tan is 11 over 21. Do you remember how to find the angle? Right, you use second tan of 11 over 21, so 27.65 degrees. You use the inverse tans when finding an angle. That's when you use the inverse trig functions, when you're finding an angle. The last thing is just some little story problems, right? So the captain of the ship, right? Captain of the ship sees angle of elevation, I can't read that, it's 12, yeah. So 12 degrees, and the lighthouse is 24 meters, and what's the distance? So that one is, and it's understood always to be a right angle. So I would say again, tan of 12 is 24 over x, or x tan 12 equals 24. So I'm going to divide both sides by tan 12. So 24 divided by tan 12, 112.91. And it looks like meters. This is the classic, the ladder's 8 feet away from the big building, 54-degree angle, how tall is the ladder? So here's our first cosine appearance. Cos of 54, 8 over x. Similarly, we're just going to divide both sides by cos 54. You want to make sure your calculator is set in degrees. So if you're like, hey, I'm typing this all in, I'm getting the wrong answer, you want to go to your mode and make sure it's set in degrees. Last one, the train track rises 800 for every 200 feet of track. There's your angle. This is a second tan kind of situation. So 8 over 200, second tan, 8 divided by 200, 2.29 degrees. So all these questions you did last year, and so this is a nice section where we just review everything with sine, cosine, and tangent.